In this video we're going to look at probability space diagrams or probability sample space diagrams, and they're diagrams that look like this, where each of these inner squares represents a possible outcome. So we might have two events in this case, where one event can have the values capital A, capital B, capital C, and the other event can have things that happen, say little a, little b and little c, and then we represent each of those things happening. So this would be where capital B happens and little c happens and so on. So in this situation I've put here there are 9 possible occurrences. So we're going to see how we put these together and how we use them to calculate probabilities. So let's look at our first example. 2 dice are thrown and their scores are added together. So when we make the sample space diagram here, we've got 6 options in one direction and 6 in the other. Those are the values from each dice. So we end up with this here. So this could be the first dice, where you could get a 1, a 2, a 3, a 4, a 5 or a 6, and this could be the second dice. And then where say this row interacts with this column, those could be the options that we get. So we add the scores together. So we get a 1 on this die and a 1 on this die. When we add them together we get a 2. If we get a 5 on this die and a 3 on this die, they add together, they make 8. So we put them there. And these are all our possible answers. So it's 6 in this direction, 6 in this direction. So that means that overall there are 36 different possible outcomes. Now we're looking for scores that are greater than 10. That doesn't include 10. It does say strictly greater than 10. So the ones that we're interested in is this one, where we get a 5 and a 6, this one where we get a 6 and a 5, and this one where we get a 6 and a 6. And it doesn't matter where those values came from, because really it's the 11, the 11 and the 12 that we're interested in. So scores greater than 10 occur just 3 times. So that gives us a probability of getting a score greater than 10 of 3 over 36. Okay, so let's have a look at our second example. This time we've got a 4-sided die, typically then numbered 1, 2, 3 and 4, and we've got a coin that's tossed. So what is the probability that we get a tail on the coin and we get an even number from the die? So when we make our diagram this time, we're going to have 2 in one direction to represent the coin and 4 in one direction to represent the die. So we end up with this, and this column is obviously what we can get from the die, and this column, row from the die, this column is obviously what we can get from the coin. And again, where they intersect with each other would be a single occurrence. So we could get head 1, head 3, tail 2 and so on. So how many different possible outcomes are there? Well, it's 2 by 4, so there are 8 possible outcomes. How many of those outcomes are a tail and an even number? Well, the nice thing is we only have to look along this row. Tail and an even number, well, that's this one and this one here. So we've got 2 occurrences where we get a tail and an even number. So that gives us the probability of getting a tail and an even number is 2/8. In the description below you can find a link to a worksheet that has questions that you can try on your own. I hope you found this video helpful. Staying in field with Winfield.